Hello, Chemistry 1A. In this recording, I am going to demonstrate the vinegar titration that is part of the hands-on lab experiment that we're doing. As always, we need to do a few things, of course, before we begin the experiment. And I'm going to point out the materials that I have on hand, and these are, of course, articulated in the laboratory procedure. I have a waste container. Anything will do. I just happen to have a beaker, but I've got a waste container. I've got the 25 milliliter graduated cylinder that was in your kit. I have the sodium hydroxide, 0.5 normal. As we said before, that is the same as 0.5 molar. I've got my phenolphthalein solution, which is my indicator, tells me when the equivalence point has been reached, and the vinegar, whose concentration it is that we're ultimately looking to determine. While I've got these, I will note that many of them have a plastic wrap around them, and so you might need a knife to carefully remove the container. I'm going to do it here for the phenolphthalein. Please be careful with this. The cellophane wrapping is on quite tightly, and if you're not careful, you could cut yourself, so please don't do that. I'm going to continue to do this while I'm speaking with you. Give me a moment. So again, I think you can see I kind of had to work at that. It is on there tight, so please don't think you're just going to be able to pop that off. Okay, so I've got that ready. I've already taken the other ones off, so now they are all ready to go. So I have those three solutions. I have the pipetter tip for the syringe that we're using as a pipette. I've got the pipette and this, the syringe that we will use as a pipette. Please note how it's together. You need to take it apart and you have to pull on it fairly firmly, right? So, it's not going to just slide right out. You probably couldn't tell that I was exerting a bit of force on that. I'm going to set this aside because we don't need it. It's this portion that we do need. And I'm going to go ahead right now and put that on there. It screws on, right? You don't have to get it real tight, just snug to make certain that there's no leaks, and we'll check for leaks later. So our burette is now ready. I have the container that we're going to be doing or conducting our titration in. It is clean and dry. That it is dry is not particularly important. That it is clean is very much important. I've set up the test tube clamp to be my burette holder. And so I'm going to position this in here now. Let me get this set up. So I've got that positioned in there now. I've got the markings in position so that I can read them. And I'm going to have that right about there so that the bottom of the burette is right about even with the beaker. If your hands are not real steady, you might want to have or use the small funnel, although you can pour directly out of the reagent containers. And some purified water, right? Tap water is likely to create problems for you if you use it. So you just a simple container of purified water. Out of screen that you can't quite see, I have some paper towels and some tissues ready. And so now I'm ready to begin. I'm going to, obviously, as you've noted, I'm going to be off camera, but I'm going to put my safety glasses on. For this one, I am going to wear gloves, and I am going to wear gloves primarily because the sodium hydroxide solution at 1/2 normal is rather caustic, right? Caustic is just another way of saying it will cause skin irritation if you get some on and forget to clean it off. Right? If you do get a couple of drops on you and rinse them off promptly, there will be no problem. But if you spill it somewhere, you really want to clean it up promptly, especially if you're doing this on a table such as I am, that I really don't want to mar the finish. So that's how we've got that set up. Okay, the first thing I want to do is get a little bit of practice using the burette because I need to get it set up so that I can dispense one drop. So I'm going to do my practice. And notice I've got the stopcock. Let me check to make certain you're going to get a good view on that. I hope you can get a good view on that. Let me bring it in just a tiny bit closer. You want the stopcock that way so that the water doesn't pour out as soon as I pour it in. So put some water in there. It really doesn't matter how much, just a little bit of water to practice with. I'm going to set that aside. Now, what you can't quite see because the video is not quite that good is down here at the tip, there's air. As a matter of fact, there's a little bit of air in there. Since we're going to be making measurements that require an initial volume and a final volume, if some of that liquid is used to fill these voids during the titration, that will create an error. So the first thing that I want to do is I'm going to turn that little stopcock. I'm going to raise this up just a tiny bit. There we go. I'm going to turn that stopcock. And again, I doubt that you can see this real well there. I have managed to get the air bubbles out of all of that. Now what I want to do is practice this so that I get just one drop out. So again, I know my hands are blocking this a little bit. So I'm turning that ever so slightly, just a little bit at a time, a little bit at a time. And again, just a little bit at a time until I get just one drop out. All right, it does take a little bit of getting used to and a little bit of adjusting. That's why we're doing all of this with water. All right, so I'm going to take that away. And since this is only water, I'm not going to be too concerned about letting one drop hit the, oops, see how quickly I gooped there. I don't know if you saw 4 or 5 drops came out. That's not the way I wanted to do it. And that's why, again, we're practicing here a little bit. I got my paper towels. I'm going to clean that mess up just a little bit. And again, I'm going to get that so that I can practice to get just one drop coming out. There we go. So again, I do realize you may not be able to see that well, but the point is to be able to work on this stopcock so that you get one and only one drop out. Okay, now having completed our practice, let me take this out there. I don't really need that. And getting all of the water down in there. Now I'm just going to let all of that water drain out. So that water drains out quickly. Fortunately, the plastic doesn't allow much water to adhere to it. But if I take, and we're going to now be filling that with sodium hydroxide in a moment, if I pour the, excuse me, where's the label? If I pour the sodium hydroxide, which is, as you can see on there, 0.5 plus or minus 0.05 normal. So for our purposes, we're going to call that 0.50 molar sodium hydroxide. If I pour the sodium hydroxide into this burette, which has a few drops of water on it, then the concentration of the sodium hydroxide will change, and that is a problem. So we need this to be thoroughly dried. So I'm going to take that out. I'm going to turn it upside down. Again, maybe you can't see, there's a few drops coming out. I'm going to take the stopcock off to get the water out of it completely. And you can see there's still some water in there. We want this dry. So I'm going to pause my video because I'm going to go over to my sink and dry and use a napkin to clean this out. And I'm going to come back in about 10 minutes. Now I'm pausing the recording, but the pause probably be about 5 or 10 minute recording while I allow this to dry off. Oops, excuse me. I need to pause, not stop the recording. Okay, I'm back again. My burette and burette tip are dry. I'm putting that back together again, nice and snug. I don't want it so snug that I break the plastic, but I do want to prevent the leaks. This goes back in my burette holder. Again, you want to be able to see the demarcations on there. I should talk about that a little bit more. So I'm going to hold it up real close. So there they are. You can see that between each milliliter, say between the 10 and the 9, there are 5 markings. Each, of course, would be 2/10 of a milliliter. So starting at the top would be 10, the next line down would be 9.8, the next line down would be 9.6, etc. When you record the volumes, my expectation is that you record to the nearest 10th of a milliliter. That does require that you make estimates. We've talked about this as relates to significant figures before. And again, to the nearest 10th of a milliliter is what I'm expecting for the volumes. And if all of your volumes end on a even number, 0.2, 0.4, 0.6, then you're probably not paying close enough attention because, frankly, only half of any of the volume measurements are likely to end up on 2/10 or 4/10 or 6, etc. Some of them need to be an odd number. So please take as much caution and time as necessary to record the volume to the nearest 10th of a milliliter. Okay, so I'm going to set that back up in here. You can see perhaps that the stopcock is lined up. I'm going to turn that now so that nothing comes out when I pour the sodium hydroxide in. So I've got that set up. I've got my sodium hydroxide in here. And the procedure, I think, says to fill it between 9 and 10 milliliters. I would like you to come almost right to the top and, just squeezing on this gently. Please don't try to cut a bigger hole in the sodium hydroxide container, right? Just be nice and patient about getting the sodium hydroxide in there. As I said before, sodium hydroxide is a caustic material. It does, it will destroy skin if you get it on there for any extended period of time. I mean, all that being said, our sodium hydroxide is pretty dilute. It is particularly corrosive to eye tissue. So a drop of sodium hydroxide in the eye and you are going to be a very unhappy camper as you try to get that rinsed out. That is why the procedure calls for the availability of water to rinse it out, either a spray nozzle on your sink or ready accessibility to a shower. So I'm going now. Stopping right there. Put the cap back on my sodium hydroxide, and I'm going to move my screen in real close to see if you can get a estimate there. Actually, what I'm going to do is I'm going to remove it from here. You know what? Before I do that, because just as before, there's an air bubble down here in the tip. So I'm going to put that under there. I'm going to turn the stopcock just enough to get the air bubble out. Now, having done that, of course, the volume went down. So now I'm going to refill that. There we go. And I'm going to remove it from here and bring it over to the camera real close. There we go. Pardon me while I take a look at it myself. Okay, so I'm putting that real close. And you see the volume, I hope. Pardon me, I'm tilting it a little bit sideways. And there we go. And I know I'm vibrating it a little bit, but what is that volume? I see 9.7 milliliters. but you can see it's, it's moving around a little bit. When you have it over here steady in the container, you won't have to remove it to take a look at it. You'll get down and get your measurement as best you can. So that volume, of course, has to be recorded. So that's your initial volume of sodium hydroxide. I'm going to take this aside now. And since it's got sodium hydroxide and a few other things in it, I need to get all of that out of there. So a little bit off camera where you can't quite see, I'm pouring that into my waste container. I'm going to rinse it out. Don't need a lot. Don't need to be skimpy, but there's no reason to waste it, right? So general rule of thumb that 3 rinses with distilled water, or in this case, purified water, is sufficient for freely soluble materials. So I've got that thoroughly rinsed out. Now at this point, there's still a little bit of water in there. I think you can see the droplets. That's not going to make any difference. I've got my graduated cylinder. I've got my vinegar. Procedure calls for 5 milliliters. So I've got that on there. Got my 5 milliliter burette. As I've mentioned, we are making, of course, a number of concessions to correct or proper procedure. Normally, you would use a pipette to transfer volumes and not a graduated cylinder. But this will do, and it will be sufficient for our purposes. Now, pardon me while I take a look at this volume myself. Okay, again, I don't know how well you can see that, but I have added 5 milliliters to that. So the 5 milliliters goes in here, but you know what? Since graduated cylinders are calibrated to contain, there's still a little bit of liquid left in there. And so only a milliliter or 2 I'm going to pour in there. Oops, maybe that was 3. It really doesn't matter. Note that I'm not recording the volume. It's not important. I'm just using that water to aid in the transfer. Now I am confident. Drop, there we go. Now I am confident that all of the vinegar that was in the original 5 milliliter sample has been in fact transferred. So I'm going to put that there. Note that I've got a clear colorless solution here, a clear colorless solution there. The products of the reaction are clear and colorless. So we need a way to indicate the end point of the reaction. We're using phenolphthalein, as we've seen before. The phenolphthalein is clear and colorless in an acid solution. I have added 2 drops. If you accidentally add 3, it's not a problem, but you don't need several drops. And in fact, that's a bit of a problem. So you see that there is, of course, no color as we expected, because phenolphthalein is colorless in an acid, that is the acetic acid. Now this next part is going to be a little bit of a challenge for you to see, and I'm going to make a change here because I think I need and want a little bit more room to work with. So I'm going to raise this up a little bit. There we go. I think that's going to be better for me and probably better for you to see as well. So I've got that in there. And now, again, I'm going to get that in real close at this point. And now you're going to see me. And what I'd like you to do is I'd like you, to the extent possible, to look down in here and watch the color change as soon as I add 1 drop. Remember, record your initial volume of 9.7 in this case. Yours is going to be a different value. So I move that slowly, and there, 1 drop. The purple color came and went so fast that you may well have missed it. I almost did. So I'm going to add 1 more drop. Oops, actually I added 3 or 4. And the color went away, again, almost instantly. Now here's where we're going to deviate a little bit from the procedure as written. The procedure as written says you add 1 drop at a time. Well, ladies and gentlemen, it's going to take well over 100 drops to neutralize that. I know the approximate amount, I don't know the exact amount, but there's no sense doing 1 drop at a time when we are nowhere near the end point. So what I'm asking you to do is to add, and watch this, add about 1 milliliter at a time. So again, let me get that set up. So watch, drip, 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 et cetera, et cetera. Okay, so I've added about 1 milliliter and the color formed and it goes away almost instantly. So you do not need to, and more to the point, you should not record those interim values for volumes, right? They have no meaning and they will only serve to confuse you later. Okay, so I turn the stopcock and add a little bit more. And I add a little bit more and you can see that purple color, and the purple color goes away. And a little bit more. And you can see if you were doing this a drop at a time, we'd be doing this for a very, very long time. So we do that, and as long as the purple color is going away promptly, we can add, again, you can see I'm just kind of twirling that stopcock. I just twist it. I get a few drops at a time and I swirl, and that color is there for a moment. And as we get closer to the end point, or more to the point, as we get closer to the equivalence point, that purple color will hang around a little bit longer. So I keep going. There's that purple color. And note that I have put a piece of white paper down here. That is so that you and I can see that pink color. If you're doing this on a dark background or something, then it's difficult to see that color, especially when it's pink. So I've got that going and we just keep going. And again, it's taking just a little bit longer after each time for that purple color to go away. Okay. So there's that purple color and it's not going away as quickly. That's because I'm getting closer to being fully neutralized. And just as an right, I started at 9.7. I'm now down to, looks like about 2.7. So I've added 7 milliliters or so, and I'm still not at the equivalence point or end point. So I add a little bit more, the color goes away. I know I'm getting close because I've got some experience doing this. And again, I know where the answer is about supposed to be. So there's that pink color. I'm going to hold that up. And again, between each addition, so I add a little bit. There's that purple color. Another drop, purple color, another drop, and again, there's the purple color, and it stays a little bit longer. Now, any experienced chemist knows that the first titration often overshoots the endpoint because you don't know exactly where it's going to be. It's kind of the nature of it. Yep. Again, I can see that as I'm getting closer, there's that pink color, and I'm turning the nozzle to get another drop and another drop. Uh-oh. Again, we can see we're real close. I get another drop. That pink color hangs on for, oops, there we go. 1 drop, and it went from clear to colorless. So that is my final amount, of course. And I can tell you, I did go a little bit past the end point because it should be just a faint pink. I'm going to get real close in here, and I see a volume of 0.90. So I've got my notes over here. I started at 9.7. I ended up at 0.9. So the difference, of course, is 8.9 milliliters. In a subsequent video, I am going to show how to conduct and complete the calculations. They're pretty straightforward, but we will go through that. Okay, so at this point, you're ready to do it all over again. And I'm not going to demonstrate that. It is the exact same thing. But let me point out what you're going to do. Well, I'll do part of it. So let's see. One, I want to point out what this looks like if you add way too much sodium hydroxide. All right. So it gets even darker. If yours is this dark, you have gone too far. Let me see if I can get real close to about the color that ideally I would like to see you have. So back titrating a little bit. This is not part of the procedure, but let me do it anyway. And by the way, you do not have any significant amount of excess sodium hydroxide or acetic acid for that matter. So you don't have the good fortune of being able to do this experiment or make any real mistakes in the experiment. Okay, so again, I'm again trying to demonstrate the really ideal endpoint if I can manage to do so. That's about as good as I can do. So again, I just wanted to show you how quickly that endpoint comes along. Now at this point, I'm going to dump out. I'm a little bit off camera. Let me get back on camera with all of this. So I've got my waste container there. I'm cleaning out the titration vessel. In this case, of course, is my beaker. I have, again, tissue or paper towel to wipe things down. Off camera, you can't see, I've got a garbage can that's immediately available to put things in. So you should have all of those ready before you get going. Now, at this point, you need to do another one. So you've got your beaker, put 5 milliliters in just as before and transfer just as before. You will need to refill the sodium hydroxide, right? You can't start over again. You'll need to refill. Now, in the titration that you just saw, I calculated that I used 8.9 milliliters. If you use 5 milliliters of the vinegar again, you can expect a number exceptionally close. I mean, arguably you could expect the exact same number, but your volume measurements may be off a little bit. Nonetheless, in my example, I needed 8.9 milliliters. Again, that just goes to my point that adding a drop at a time initially is not necessary. Your second titration, again, is going to use, approximately speaking, the same amount of sodium hydroxide. The other thing I'll point out, and again, I don't know how well you can see this, but right, that's the sodium hydroxide that's left in there. You've got enough to do 2 titrations, maybe 3, but you don't have enough sodium hydroxide to make mistakes. And then, yeah, you just don't have enough sodium hydroxide to make mistakes. At this point, the experiment is over. And again, I want to point out, I did 1 titration. You need to do or perform a second one. So at this point, it's cleanup time, all right? Everything cleans up exceptionally well with just still water. So I'll pour that in there into my waste container. This is now clean. I'm going to set it aside. I'm set it up here. I've got my waste container. This can be flushed down the drain. I'll do that off camera, but this is just going to go get flushed down the kitchen sink. Set the vinegar aside. Whatever you pour this on, or pardon me, whatever you do the titration on, you should of course that up. Now I was quite careful and a little bit lucky in that I didn't spill or get any drops going into stray locations, but you'll want to wipe down your surface with just a damp paper towel when you're done and clean up everything. So at this point, our recording is done. Again, there will be another recording that walks through the calculations based on the data that you just saw in this titration. Thank you.